Hey guys, it's Miss Clark. Today I'm going to walk you through 1.4 notes, literal equations and formulas. Just a reminder, if you want a more completed look at the notes, you can go to the website and it will have all of the notes filled out for you. Today I'm just going to walk you through a few examples so you can get the gist of what solving a literal equation looks like. So before we get started, I want to talk about what is a literal equation. So we might have heard the word literal before. We would say, oh, I literally broke my foot, or I literally fell down the stairs. But this is actually a different definition of literal. So I'm going to scoot down here. So we're going to use the word literal to mean made up of letters. So I like to think of it as literal. It kind of helps me remember it. So a literal equation has a bunch of letters. So like I said, so that means that if literal means to be made up of a bunch of letters, then a literal equation would be an equation that has a bunch of letters in it. But in math, we usually refer to letters as variables. So a literal equation is going to be an equation made up of mostly variables. And we see this a lot in real world examples where we talk about, we use variables for temperature or height or distance, velocity. And so we'll have often a lot of letters in one or a lot of variables in one equation. Not super important. I just wanted to give you an idea of why it's called a literal equation. So our goal today, our objective is going to be use the properties of equality to solve for the indicated variable. So that's just a fancy way of saying we're going to solve these equations for just one variable. So let me scoot down to 1 through 6 and I'll show you more what that looks like. Stop chit-chatting. All right, so I'll scoot in a little bit just so we can get a little bit. And I'm going to do examples 1 through 3 for you. And so the key word here, it says for 1 through 6, solve for the requested variable. The key word here is going to be requested. So we can't really solve for a variable unless we know what variable we're looking for. So if we look at example 1, it says A equals BH, solve for H. That means that we're going to go through and we're going to solve for the letter H, which means if I come over here to my equation, A equals BH, H is the variable I want to get all by itself. Now, I know this looks a lot different, but just a reminder that variables represent numbers, so we can treat them like numbers, and so we're going to solve these equations just like we would a regular equation. So if I have A equals B times H, then I'm going to divide by B to get H by itself. I'm going to divide by, let me rewrite it down first, just so it's bigger. A equals BH. Again, that's multiplication happening in between the B and the H. So I'm going to undo that multiplication with division. I'm going to divide both sides of my equation by B. You can see my B's cancel each other out over here. And I have my final answer, A over B equals H. Or I can rewrite this as H equals A over B. Okay, so going through example 2, same process. So it says, first thing I need to look for is what variable am I trying to get by itself? And it says solve for A. So I'm going to focus on getting this A by itself. So I need to move everything else on that side of the equal sign. I'm going to start by subtracting 2B and subtracting 2B. And I'm going to go ahead and draw a little line here so I can keep track of my steps. I didn't do anything with this 5A, so it's just going to come straight down. This plus 2B minus 2B, that goes to 0. You can cross those out, and then I have 40 minus 2B. Now, the biggest mistake that I see people make here is they go, oh, 40 minus 2, that's 38. This must be 38B. But careful. This 2B is attached to or this 2 is attached to this b. So we can't combine it with the 40 because these are not like terms. So I'm just going to keep this 40 minus 2b over here. Really, at the end, it's fewer steps. We don't have to do anything to put them together. We're just going to leave them as they are. They're not like terms, so I can't put them together. So I have 5a equals 40 minus 2b. And then the last step to get a by itself, I want to divide by 5. And I'm going to divide this side by 5 as well. What color do I want to use next? Purple, I guess. I just like to use a lot of colors. So my 5s divide each other out here. And I'm going to distribute this 5 to both of my terms. It's just like we distribute multiplication, we distribute division. So I have a on my left side, and I have 40 divided by 5 minus 2b divided by 5. So this is going to simplify down. 40 divided by 5 is going to give me, it's going to give me a equals 40 divided by 5 is 8. And then I'm going to just put that fraction in front of my b because it just is prettier that way. So minus 2b, oh sorry, minus 2/5 b, like that. So I just sort of, this is 2 times b up here, I just sort of move it to the side. I get a equals 8 minus 2/5 b. And then last one over here, going to number 3, I have v equals 1/3 LWH. Now this is interesting here because it says solve for W, and I have a whole bunch of things being multiplied to my W right now. So there's a lot of ways we can do this. We can divide out one by one, or we can just kind of get rid of it all at once. What I like to do is when I see equations with a fraction, I just like to deal with the fraction first, get it out of the way. I don't want to look at it. Don't want it to be there, so I'm going to rewrite this just so I have some space. I have v equals 1/3 LWH. And I'm going to get rid of this fraction first, so I'm going to multiply by the reciprocal. So I'm going to multiply both sides by 3/1. Or you could just multiply by 3. Same diff. And then that's going to cancel out on this side. And I'm going to get 3v is equal to LWH. And now I want to get this W by itself. And since both the L and the H are being multiplied by the W, I'm just going to divide them both out. So divide by L and divide by H. And then those L's are going to cancel, those H's are going to go away as well. And I have 3v over LH is equal to W, or W is equal to 3v over LH. All right, so at this point, I would like you to pause the video and try doing number 6 on your own. I'll give you, well, you can have as much time as you want because you're going to pause the video. But go ahead and try this one right here for yourself, and then we'll come back and go over the solution. Alrighty, so number 6, let me scooch on down here. All right, so again, we're going to solve this. And it says solve for y. So I'm going to get my y variable. Oh my God. I'm going to get my y variable by itself. So I want to get this y over here by itself. So that means I'm going to get rid of my 2 and I'm going to get rid of my 3x. So I'm going to subtract my 3x first because it's kind of hanging out all by itself. Minus 3x minus 3x. These go bye-bye. And I get 2y equal to, just a reminder, these are not like terms, so I don't combine them. This is just 12 minus 3x. Then lastly, I divide by 2. Cross out. Distribute my 2. Y equals 12 over 2 minus 3x over 2. This simplifies, and I get y equals 6 minus 3 over 2x. Okie dokie. Last but not least, we're going to go over a word problem just so we get a good idea of what that will look like. Because literal equations often represent real world things. So it says example 9. We're doing this one right here. In a half hour, Sarah is meeting her friends at the lake, which is 6 miles from her house. At what average speed must she ride her bike to get there on time? If distance equals rate times time. Or sorry, if D equals RT, where D is distance, R is rate, and T is time. Sorry, I just want to assign the variables. All right, so we have the equation D equals RT, where we have D is distance, R is rate, T is time. And it says, at what average speed must she ride her bike on time? So that means that we're looking for speed. That's what we want to get by itself. And so we have distance, rate, and time. Rate, or R, is going to be what is representative of our speed. So we're going to take this equation right here, and we're going to solve for R. So I have D equals RT. And I'm going to get R by itself, so I'm going to divide by T. And so my equation solved for R is going to be R equals D over T. Now I'm not done because it's asking what her speed is, given that we know she is 6 miles from her house and she was there in a half hour. And since time is in hours, we're going to say that this is really 0.5 hours. So we have that our distance D is 6 and our time T is 0.5. So we're going to plug those into our equation. So I have R equals D over T. So that's going to be equal to our distance, which is 6, over our time, which is 0.5. And I'm just going to plug this into a calculator. This is going to give us a rate of 12. And we're going, our units are miles and hours. So this is going to be 12 miles per hour, or 12 mph as we like to use it. All right, so that's a quick walkthrough of literal equations. Thanks for stopping by.